Namaste. Welcome to First PUC Computer Science video classes, Chapter 1 Computer System. After studying CPU and the different components of CPU, that is ALU and control unit, then we moved on and studied the various kinds of input devices, the use of input devices, and the example of input devices, and also the output device, function of output device, different types of output device, what is hard copy, what is soft copy. Now, another important unit in computer system is computer memory. A computer memory is a remembering unit in computer. All the data, instruction, processed result, intermediate result, everything will be stored in the memory. The computer system needs memory to store all kinds of data and instructions for the purpose of processing. Memory stores data. How do we measure the data? We need some unit to measure the data. In computers, whatever the data we feed, as I told in my earlier lecturing, suppose I type letter A, suppose I enter value 10 or value 25,000, it will not be stored in that form. It will be converted into a digital form. What is digital form? A digital form is the machine understandable format. What is machine understandable format? It is a language that consists of zeros and ones, which is called as the binary digits. Binary language is the language of your computer. Then, whatever the data I enter into the computer system, when it is stored in the memory is not abundant. Memory is a limited resource. I think you might have experienced in your smartphone usage. After storing many photos, you will see that there is no memory left out. It is all because of storing the photos in a large quantity in the memory of the smartphone, and the memory is limited in size. You want more memory, you have to pay more money. From this, what we can understand, a memory is an important resource and it is limited and it is expensive. Now, how do we measure the memory in computer? We use a specific unit. The basic unit of the memory is binary digit. In short, we call it as bit, B-I-T, bit. Bit full form is binary digits. 0 and 1 is the example for binary digits. These are the basic units of binary digits. These binary digits are grouped together to form words. How many binary digits are grouped to form a words? There are two kinds of words. One is called 4 bits word called as nibble, 8 bits word called as a byte. 8 bits word called as byte, 4 bits word is called as a nibble. In this slide, you can see the various measurement units for digital data. To start with, bit is there. This is 0 or 1. Each 0 or 1 is called a bit. Full form of bit is binary digit. Then 4-bit word is called as nibble. 8 bits word is called a byte. 1024 bytes is called 1 kilobyte. 1024 kilobyte is called 1 megabyte. 1024 megabyte is called 1 gigabyte, and 1024 gigabyte is called 1 terabyte, and 1024 terabyte is called 1 petabyte, and 1024 petabyte is called 1 exabyte, and 1024 exabyte is called 1 zettabyte, and 1024 zettabyte is called 1 yottabyte. These are the various measurement units for digital data in memory. There are different types of memory in computer system, namely primary memory, secondary memory, and cache memory. Primary memory means the main memory of computer. The program and the data are loaded into the primary memory before processing. The CPU communicate directly with the primary memory to perform read operation or the write operation. The primary memory consists of two types, namely random access memory, in short it is called as RAM, and read-only memory, in short it is called as ROM. The primary memory limitations are, normally it comes with limited storage capacity, and it is either volatile or read-only, and it is expensive, costly also. Limited in size, but it is expensive. There is a volatile memory and there is a read-only memory, nothing but the non-volatile memory. Students, what is primary memory? Let me explain like this. Basically, the data what we store in computer will be temporarily stored in the primary memory. Temporarily stored in the primary memory. Let me take myself an example. If I want to store any information without a book or using any written storage medium, where do I store? I store it in my brain. I have neuron cells in that I can store. Can I store that information permanently forever? Can I repeat the same words tomorrow or after 10 minutes or after 15 minutes? What I said before 5 minutes or 10 minutes, can I recall as it is and tell you? That is not possible. But whatever I recognize will be stored initially in my brain. It will be initially stored. Exactly like this, your primary memory in computer. If the CPU wants to use the data, that data should be stored in the primary memory of the computer. If the data is not present in the primary memory, then your computer cannot process any data if it is not available. It can access only the primary memory. Remember, we have a secondary memory, we have a cache memory. But first thing is, it can directly communicate with the primary memory, not with other types of memory. Therefore, it is named as primary memory. But the data in primary memory is not permanently stored. That means any data is available in the computer in the primary memory during the functioning of computer. As and when computer is switched off, all the data stored in the primary memory will be erased. Therefore, we call it as primary memory as temporary memory, but it is main memory of the computer. Random access memory, RAM, is the main memory of the computer. The nature of RAM is volatile. It is a volatile memory. What is the meaning of volatile? Any data stored in this RAM during the functioning of computer system. When computer system is switched off, all the data stored in the RAM will be automatically cleared. We don't give any instruction. It will automatically erased if the data is stored in the random access memory. Without storing into the data random access memory, we cannot give it to the CPU. Through RAM, only all the data will be sent to the CPU for further process. But it is volatile. It stores data temporarily. It is faster than secondary memory or any other storage devices. There is another type of memory in the main memory, that is read-only memory. In short, it is called as ROM. It is a small memory but faster permanent storage for the contents which are rarely changed. What kind of instructions are the data stored in the ROM? The startup program or the bootloader program is stored in the ROM. When we switch on the computer, the ROM supply the startup program to the CPU. Then onwards, it is going to load the operating system into the primary memory of the computer, that is the random access memory. So operating system files are basically not initially automatically stored into the main memory of the computer. The first program starts when we switch on the computer is startup program. It is also called as bootloader program, and this bootloader program will be present in the read-only memory. Any data stored in the read-only memory is permanent. That means it is non-volatile memory. That is, even though I switch off the computer, no data will be removed, no data will be cleared, no data will be erased. It will be there forever. In fact, once a data is written into the read-only memory, it is permanent. It is like a printed book. Can you change the content of the printed book? No, you can't change. Your normal notebook where you use to maintain the notes, that is random access memory. Your notebook is a random access memory. Your printed textbook is a read-only memory. Like that you can understand the main difference between RAM and ROM. What is RAM? Is a main memory. The data will be stored temporarily in the random access memory. The data once written in the read-only memory is permanent. It cannot be changed. It cannot be erased. It cannot be deleted. Cache memory is another type of memory in the computer system, cache memory. On this slide, I have two different diagrams. One diagram here, this diagram shows there is no cache memory, and this diagram includes the cache memory. Now let me explain the difference between without cache memory and with the cache memory. My program and data will be stored in the main memory of the computer system. The CPU can directly access those data and instruction which is present in the main memory, and it can use for processing. Every time the data or instruction is required, the CPU will search that data and instruction in the main memory. Already used data or newly searched data, everything will be looking at the main memory the CPU access that location, gets the required data. This way of processing takes a lot of time. This reduces the speed of the CPU. Though CPU can do a lot of work in very little time, but every time it has to visit to the main memory for data and information, fetch that data and instruction and execute, takes a lot of time. Not because of CPU cannot work. Though CPU is capable of executing more and more instruction, but non-availability of data and instruction makes the CPU work slower. To enhance the CPU work or to enhance the speed of the CPU process, the cache memory introduced in between to the CPU and the main memory. Now let me explain the same process with the cache memory. The CPU goes to the main memory for the data, it gets the data and uses it for the process. The copy of the data will be stored in the cache memory. Like this, after many data is used by the CPU and after processing, if the same data it wants, which is already used by the CPU, if the same data if it wants, the CPU doesn't go to the main memory, it goes to the cache memory. From the cache memory, it can easily search the used data and immediately it gets that data and process that data or the instruction. So the used data and instruction, copy of that will be present in the cache memory. Already used data and instruction, it won't go to the main memory, it goes to the cache memory. From the cache memory, it fetches that data or instruction and processes it. This enhances the processing speed of a CPU. In the absence of cache memory, every time it has to go to the main memory, gets that data, whether it is already used or not, every time it has to move to the main memory for the data and instruction. This takes a lot of time. That time can be saved by introducing the cache memory. Secondary memory. It is another type of computer memory where we can store the data permanently. And normally the secondary memories comes in a larger storage capacity. It is cheaper, it is less expensive compared to main memory of the computer system, but it is slow. It is used to store data and information permanently. It is a non-volatile memory. That means any data stored in it will not be automatically erased whenever we switch off the computer. All the data and instructions stored in the secondary memory will be securely stored until and unless we erase it or we change it. We can frequently make suitable changes in the data or the instruction what is stored in the secondary memory. We can also make copies of the data and instruction. We can move from one place to another place. There are different kinds of secondary memories. We can have multiple copies. The example of secondary memory is hard disk, SSD, pen drive, CD-ROM, DVDs, etc. The main disadvantage of secondary memory is any data or instructions stored in the secondary memory is not directly accessible by CPU. That means the data stored in the secondary memory must be sent to the primary memory or the main memory of the computer, then only CPU can access. No data can directly accessible by the CPU that is stored in the secondary memory. If any data is stored in the secondary memory, if you want to process that, then what we should do? We should send that data into the main memory. Then only the CPU can use that data and process the data. Suppose you want to store any data in secondary memory, from where we can store the data permanently in the secondary memory. From the main memory, the data is permanently stored in the secondary memory. Okay. So, in between the CPU and the secondary memory, the main memory will be there, because CPU can access directly the main memory and not the secondary memory. These are the secondary memory examples. Very common devices are hard disk and the SSD. These are the latest secondary memory hard disks, that is a solid state drive. Then the optical disks are there. External hard disks. Easily we can move from one computer to another computer when compared to hard disk. Hard disk is built into the CPU. That means it will be present inside the CPU cabinet. We can't remove and take it out. Whereas external hard disk can be easily attachable with the help of a USB. Then when and you can take it out and you can insert in some other computer to access the data stored in the external hard drive. So we have magnetic diskettes. These are the magnetic diskettes were used in the olden days. Now it is not that much useful, and you might have not seen this disk at all. But USB flash drives are there. In simple terms, we call it as a pen drive. These pen drives are a portable secondary memory. And we have memory cards used in the laptops or the digital camera or any other such devices. Okay. And magnetic tapes. These are also very old kind of secondary memory. So very latest we have hard disk and the solid state drive, optical disks are there, and the pen drives are there. Now let us understand the data transfer between the memory and CPU. When I say memory, don't get confused with cache memory. Is it a cache memory? Is it a secondary memory? Is it a primary memory? The answer is primary memory. Memory means primary memory. The two, the data transfer between CPU and memory means it is the main memory. Which one is the main memory? The random access memory or read-only memory is the main memory of our computer system. How are data transferred between CPU and the main memory and between main memory and the secondary memory? The data transfer takes place between the CPU and main memory, between main memory and secondary memory using physical wires, and these physical wires are called bus. The bus is used to transfer data between the CPU and memory. The CPU access the memory and the memory send the data to the CPU using the bus. There are different kinds of bus. What are the different kinds of bus? One is the data bus, another one is the address bus, another one is the control bus. The data bus, address bus, and control bus, all the three bus is called as the system bus. So what is system bus? The system bus includes control bus, address bus, and the data bus. What is basically the bus? Why it is used? What is the function of a bus? A bus is a physical wire that carry the data between CPU and the main memory, or from main memory to secondary memory. What is the function of a data bus? The data bus function is to transfer data between different components, and it is bidirectional. The bidirectional in the sense, in two directions the data can move. The address bus. The address bus is used to transfer addresses between the CPU and main memory. The address of the memory location that the CPU wants either to read or to write from the specified address in the address bus, and it is unidirectional. Unidirectional in the sense, in one direction the data moves. What kind of data? The memory location address data moves from address bus to the CPU. From data bus, the actual data from a particular location moves from main memory to the CPU. What is a control bus? The control bus is used to communicate with control signals like read or write between different components of computer, and it is also unidirectional. Unidirectional means in one direction only the data moves. All the three buses collectively makes the system bus, as I earlier explained. Now, let me take a very simple example and explain the uses or the functions of the data bus, address bus, and the control bus. Now you see here. Now there is a data stored in the memory. Many data are stored in the memory. I am searching a particular data. Where is the data stored? In any location of a main memory. How do we address that location? A computer has a mechanism to address each and every location of the memory. That means it is like a house address. It is like a SIM phone number. Okay. How do we identify one phone number with another phone number? There will be a unique number given. How do you identify your friends or relatives' address? By door number, street name, etc., name, etc., etc., right? Likewise, in computer, the data is stored in the memory, and each data has an address. Okay. Whenever CPU wants to fetch data, it will generate a read signal because it wants the data for further process. The data is already present in the memory, right? Suppose I ask you, start reading the second chapter of the English textbook, then you will open the second chapter and start reading it. Are you going to write that time? No, you are going to read. Read is nothing but already some information is present and you are going to read. That means whenever CPU wants some data for process, it will approach the main memory, and the control bus will initiate a control signal. Which kind of control signal? There are two kinds of control signal. One is the read signal, another one is the write signal. Which one it has to initiate? Read signal. Okay, the read signal, control signal, when sent to the memory, the address bus is going to give the location of the data stored. It is going to give the address of the data. Just gives the address of the data. The data is not moved yet. That address, from that address, the data flow to the CPU through data bus. So data bus can move the data from the memory to CPU only when control signal send the read instruction along with the location address of the required data. Okay, so the address bus carries the location address of the required data, and the data bus carries that data from that location. The control bus will initiate the control signal either to read from that location or write the data to that location. Now you have understood what is the read operation. Now let us understand what is the write operation. Now I have entered, say, 6 subject marks. I want to calculate the total. Now my 6 subject marks stored in the main memory of the computer system. The CPU initiate the read signal. The control bus will generate the read control signal. The address bus will search subject 1 marks location. From that location, the subject marks will be carried through data bus to CPU. Of course, in CPU, registers will be there. The data will be stored in the register. Okay. Like this, for all the 6 subjects, the same process takes place. So all the 6 subject marks now present in the CPU for process. What kind of process? For totaling. It is going to sum up. Now it is going to calculate the total of all 6 subject marks. Now we got the total marks generated by the ALU. Now this generated result must be stored in the primary memory. Where it has to be stored? It has to be stored in the free location of the primary memory. The control bus will send the control write signal, then data cannot be immediately sent. If the data is sent, where it has to be stored? It requires an address. The address bus will give the free memory location, address location for the data, the total marks data that has to be written in the main memory. Once the address bus sends the address location for the generated result data to be stored in the primary memory, then the data bus carries that data to the address specified by the address bus, and it writes there. It stores there. Write is nothing but storing. Read is nothing but fetching. Like this, the different bus are used for different purposes. All these 3 bus makes the system bus. So far you have understood how read operation and write operation takes place in the memory. Now what does the data bus carry? It carries the data. What does the address bus carry? It carries the address location for the data. What does the control signal carry? It carries the either data signal or the write control signal or read control signal. Now the question is, how is the transfer from memory to CPU or from CPU to memory takes place? The data transfer from memory to CPU and CPU to memory takes place through a dedicated hardware called memory controller. When CPU initiates the read operation, it specifies the address and the data is placed on the data bus by a dedicated hardware called memory controller. So the memory controller manages the flow of data into and out of the computer's main memory. You can see here the block diagram of a microcontroller. There is a CPU. The CPU will send the address through address bus and the data is carried through data bus, and the control signal, that is read control signal or write control signal, will be sent through the memory controller. Basically, the memory controller is a hardware that manages the flow of data from CPU to memory or from memory to CPU.